Hello geographers and welcome to your coast lesson today. We're going to be looking at erosional landforms and we're going to be looking in particular at cliffs and wave-cut platforms. My two little boys love wave-cut platforms. They love being taken down and they love exploring all the rock pools and seeing what they can find. You're going to need 5 things today, so I'm going to go through them twice. You need a pen, a pencil, a ruler, a calculator and a piece of paper. So 5 things: pen, pencil, ruler, calculator, piece of paper. I'm impressed I remembered. So while you go and get them, make sure you clear all the distractions around you away, or consider going to move somewhere quieter where you're not going to be disturbed this lesson. So off you go and get them, and I'll see you back in a second. Brilliant. So the title today is Erosional Landforms 2. We're going to look at wave-cut platforms. So right at the top of your page for me, underline it, and we'll be ready to go. How do cliffs form? Let's start to have a look. Cliffs are created by coastal erosion at the base and weathering higher up. Geology also plays a role. If you have resistant rock, they tend to form steep cliffs like you can see in the image. You've got an incredibly steep cliff there, and it's got a really vertical face. However, if you have cliffs created on soft rock, the soft rock erodes quicker, creating gently sloping cliffs. And in this image, you can see that slumping has occurred because you can see that kind of curved slip plane, and you can see where sections of the cliff with grass are now halfway down. Let's have a quick test. Which processes create cliffs? Erosion, longshore drift, deposition, or weathering? Choose 2 of them for me, please. 5 more seconds. Right, how did you get on? So the processes that create cliffs are erosion. So waves are going to erode the base of the cliff through hydraulic action and through abrasion. The other one is weathering. And weathering will occur on the tops of the cliff, and we would get mechanical weathering and we would get chemical weathering. Next one, steep cliffs are more likely to form when the rock is, it's a nice quick one, so 3 seconds. 1, 2, 3, hard rock. So resistant rock is going to give those steep cliffs. If we've got soft rock, we're more likely to have slumping, and we're going to have those gentle cliffs. Now time for a task. In geography, we get tested on our ability to manipulate data and to use math skills. This table shows us the data for cliff erosion between 1980 and 2015. It tells us how many meters of erosion has occurred every 5 years, and it's in meters. What I would like you to do using your calculator is to calculate the mean yearly erosion rate between 1980 and 2015. And then I would like you to calculate the modal erosion rate. If we remind ourselves what these maths terms mean, so mean is the total number of data sets added together. So we're going to add up all the information from those 8 sets of data, and we're going to divide it by the number of data sets. So there is 1980, 85, 90, 95, 2000, 2005, 2010, 2015. So that's 8 data sets. So the mean is all the numbers added together divided by 8. Mode is the most common, and I remember it just by those first 2 letters, M-O. Mo is the same as most, M-O. So the most common. So you're going to look through those data sets and decide how many meters of erosion is most common. Right, it's time to tackle it. Pause the video and press play when you're done. Let's check those answers. Mean, the total of all the data sets added together. So what we're going to do is we are going to add up 0.5 plus 0.8 plus 1.2 all the way along that row. That gives us a total of 9.3 metres. And we're going to divide that by the number of data sets, and there are 8 data sets. 9.3 divided by 8 gives us an answer of 1.16 metres, or 1.2 metres if you round it up to 1 decimal place like the table does. Something I want you to check is, have you got the units? Have you put metres? It's really important that we add units to our answers. The mode is the most common, so which number appears most frequently? If we look along that table, it is only 1.1 that repeats twice. So the mode of this data is 1.1 metres. Well done. It's tricky, but if you take it slowly, it's easy to achieve these maths questions. Now let's have a look at how wave-cut platforms form. Here's a picture of a wave-cut platform. So you've got your tall, steep cliffs, but at the base of those cliffs, there is a wide, flat, rocky platform. Destructive waves erode the cliff through processes such as abrasion. There's a video about erosion processes if you want to have a look and revise those. But if not, abrasion is the wearing away of cliffs by sediment flung by the breaking wave. And that sediment acts like sandpaper and it wears away the cliff. Waves erode the cliff between the high and the low tide lines. Over time, that erosion creates a wave-cut notch, and you can see that in the diagram now. And that notch has become the size between the high and the low tide line, because that's where the waves are eroding. This notch gradually gets larger. But there's a bit of a problem, because if we now look at the cliff above the wave-cut notch, it's unsupported. There's nothing there holding it up. So mass movement occurs as a result of gravity, and that cliff will fall into the sea. That means that the cliff has retreated, and that means moved back. So you can see with the dotted line where the cliff was, and now part of that cliff has fallen into the sea, the cliff line has moved back, the cliff has retreated. We've used the process in there, mass movement. Mass movement is the downward movement of material under the force of gravity. The wave-cut platform is the uneroded section of the original cliff at the base. So if you see right at the bottom of the diagram, that used to be the cliff, but the cliff above it has eroded or fallen into the sea, but that wave-cut platform is the bit of cliff that is still left intact. But the process is going to start to repeat again now, and we will have a new notch forming. Cliff's going to retreat and retreat and retreat. Your turn. So what is at A? Can you remember? 3 options, just 5 seconds for this one. Yes, you got that one easily. So wave-cut notch is at A. And remember, it's the high and low tide that determines the size of that notch. What is it at B? 5 seconds. B is the wave-cut platform, so the bit that hasn't been eroded, wave-cut platform. Why does the section of cliff at C collapse? Which one are you going to go for? 3, 2, 1. It is gravity. So it becomes unsupported because the notch means that the rock underneath is removed. There's nothing supporting it. So the weight and gravity are going to cause that to fall as mass movement. Time for your task. Identify the missing words in the explanation below. In white, I've given you the words you can choose from. Wave-cut platform, wave cut notch, high, gravity, repeats, destructive, abrasion, unsupported, and retreats. So you've got 9 words there, and there are 9 letters in the paragraph of information that I want you to match those to. You can just jot down letter A equals. Alternatively, if you want to write down it all, then feel free. So pause the video now to complete your task and resume once you're finished. Let's see how you got on. A was destructive. So destructive waves erode the cliff between high and low tide line through processes such as abrasion. Over time, this erosion creates a wave cut notch. This wave cut notch gradually grows larger and the unsupported cliff above it falls due to gravity. We could talk about that being mass movement if we want to be super impressive. This means the cliff retreats. The uneroded original part of the cliff left at the base is the wave-cut platform. Over time, this process repeats. So the words, in order as you wrote them down, destructive, high, abrasion, wave-cut notch, unsupported, gravity, retreats, wave-cut platform, and repeats. Well done, everyone. And now, as geographers, everybody loves a good map. I love having a look at the map spread out in front of me and seeing what I can see. But what do coastal landforms look like on a map? Let's have a look now. This here is a 1 to 50,000 OS map, Ordnance Survey map. You can see that it shows the coastal area around Kimmeridge. Around Broadbench and Howbarrow Bay, you can see that there is kind of cloud shapes coming off the side of the coastline. If we zoom in to have a look at what I'm talking about, you'll notice it looks a bit like this. This is a wave-cut platform. So on a map, they look like bumpy edges along the coast and they stick out to sea. Also in here, we have cliffs. And cliffs are the opposite. So cliffs are set back from the coastline. So they are small black semicircles set back from the coastline. So on that image, we've got a wave-cut platform and a cliff. It looks a little bit different on a 1 to 25,000 map. So this zooms in and you get more detail. Here you can see the wave-cut platform has got lots more detail. If I just flip between the two, they will look different on the different maps. Okay, so we're sticking with the 1 to 50,000. Which square contains the wave-cut platform? A, B, or C? 3, 2, 1. And it is A. So just above the V and the E in the word cave, you've got a wave-cut platform. Now we're looking for cliffs, and this time there are cliffs in 2 of the squares. Write down your answer. In A, you have no cliffs. What the coast looks like in that image is a wide sandy beach. So B and C both show cliffs. These are the semicircles that are set back from the coastline, so from that main black line that shows the edge of the coast. Time for a task. It's quite a tricky one. I would like you to create an annotated diagram to explain the formation of a wave-cut platform. An annotated diagram means that you've got not just labels, but almost entire sentences to explain what is happening. I've given you a diagram to help you, and it's really important you draw this in pencil for me. Because we're looking at the formation of something, we want to make sure we get the sequence right. So first this happens, next this happens. And to do that, when we're annotating a diagram, you could use number bullet points to show which piece of writing you want the examiner to look at first. Words that I would expect to see in an excellent answer are high tide, low tide, wave cut platform, retreat, wave cut notch, abrasion, mass movement, and gravity. So see if you can challenge yourself and get all 8 of those in. Good luck. Pause the video now, have a go, and then we'll come back together and see how you've got on. Don't forget that pencil. I am looking for then a clear diagram. We're not looking for a Picasso work of art, which is lucky. Numbered statements. Okay, so have a look at your writing. Did you put numbers so you know which order to read them in? And we're looking for keywords. Number 1, destructive waves erode the cliff through abrasion between the high and the low tide lines. So at any stage, if you think you need to add something, just quickly add it on. Number 2, a wave cut notch forms, and this gets bigger over time. Number 3, the unsupported cliff above falls due to gravity or mass movement. Number 4, the cliff retreats. And finally, number 5, the uneroded original section of the cliff remains as a wave cut platform. So add all your ticks. If there's any keywords you need to add in, pause the video and do so now. Well, that brings us to the end of today's lesson. We've learned about cliffs and wave cut platforms. Remember, they erode between the low and the high tide line. What impresses examiners, though, and teachers is you being able to use specific processes. So when you're talking about that cliff eroding, make sure you're saying it's eroding through abrasion or eroding through hydraulic action. But while our cliffs might be retreating, it is vital we do not let our knowledge retreat over time about coastal landforms. So I'm going to ask you to click to the next page and think really hard about what we've learned today so we can ingrain it into our memories by completing the quiz. Thanks so much for your time today. Take care, and I look forward to you joining me soon as we start to have a look at arches, stacks and stumps. Have a great day, everyone.